Hello everyone, welcome back to our Calculus 2 course. Today I'm going to be talking about power series. It's in section 11.8 and 11.9 in our books. In 11.8 we'll be talking about power series. I'll introduce you power series and how to find the radius and the interval convergence. And then on 11.9 I'll be talking about presentation of a function. That's a power series. So let's start with 11.8, power series. 11.8. Powers series. So first I'll give you a definition. A power series is a series that looks like this. Cn x to the n from 0 to infinity. So what we're trying to say is this. You have a series look like this. C0 plus C1 times x, C2 x squared, C3 x cubed, da 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 da. You guys can think of this as a polynomial. Remember, you learned this is a constant, this is a constant, right? And then with x, you have a linear function, polynomial of degree 1. X squared, this is a quadratic function of polynomial of degree 2, and then degree 3, 4, 5. So think of power series is like a polynomial of degree infinity. Keep going forever, okay? Where in general, C1, C2, C3, or Cn in general, are constants. And then we call them the coefficients. Coefficient. Okay, those are coefficients, just like in polynomials. Okay. Then we can find a more general definition of this one. This one actually is polynomial of degree infinity. Okay, called this way, power series center at 0. Then we're going to define a power series this way, a little bit more general. Let me get a better marker. Cn x minus a to the n. Okay? It's the same thing. It just have a constant a right here. This is what? C0, C1, x minus a, C2, x minus a squared, C3, x minus a cubed, plus da da da, get forever. This is a more general definition of a power series. And this is a power series center at A, okay, where A is a constant. It's a constant. Okay? So this one is actually what a power series center at A equal to 0. See, x minus 0, x minus 0 squared, x minus 0 cubed. This is more general, where A could be any constant. And again, this is more general definition of power series. So we start with this, and we have a more general definition of power series. So let me give you examples. Example. If all the Cn's equal to 1 and A is equal to 0, then you have what? The sum of x to the n, which is 1 plus all the c's are 1, okay? And x minus 0, a equals 0. So x minus 0 squared, so what? X plus x squared plus x cubed, x to the 4 plus da da. A simple one, and you recognize this. This is a geometric series. Okay. Let me give you another one. How about this? Cn is equal to 1 over n factorial. And you have something like this. Sum of 1 over n factorial x to the n, n from 1 to infinity is what? 1 plus x plus 1, x over 2 factorial, x squared over 2 factorial, x cubed over 3 factorial, x fourth over 4 factorial plus da da da. Okay? We call that n factorial, where n factorial means what? 1 times 2 times 3 times da da da, all the way to n minus 1, then times n. Okay? This is also another power series. Okay? Center at 0. So after a couple of examples, you see the idea of power series. We just think of x like the variables. Okay, we'll start with no x, so that x and x squared, x cubed, x4, x5. It's like polynomial, but polynomial gonna stop at x equal to a fixed whole number somewhere. But in power series, keep going forever, so we never stop. So n go to infinity. Okay, so the main question we're gonna tackle in this section is, under what value of x that power series will be convergent. Okay. So obviously, you see, let me just talk about the definition where center is 0. Of course, center as a is similar. It's the same way. It just changed a little. Okay. You see that this power series is always convergent when x equal to 0, right? Because when x equal to 0, this power series is just equal to a constant right here. And you know that if the power series equal to a constant, we say that the series is convergent. It's convergent. It's convergent. X equals 0 right here. Or I can write it in more general convergence. Okay. What about this? Cn of x minus a to the n, which is c0 plus c1 x minus a, c2 x minus a squared plus dot. When x equal to a, then that power series, when x equal to a, make all the terms right here equal to 0. So the power series is just equal to the first term, and the series is also convergent. Alright. Now you may ask, beside that x equals 0 for this first series, so beside x equal to a, under what other values? Are there any other values that make the series convergent as well? Okay, and the answer is sometimes yes, sometimes no. We gotta figure it out. And the main test that we're gonna use is gonna be the ratio test. But let me give you an example. You see, actually the example that you have already. This one for Cn equals equal to 1, then you have the sum of xn equal to 1 plus x squared x cubed. This series is not just convergent at x equal to 0. It is convergent for any x, not equal, between -1 to +1. Let's cut the what? Interval convergent. Or you write this way, you see interval. X is between -1 to +1. Okay. So x not just converges in the series, not just converge when x equal to 0. When x equal to 0.1, 0.2, 0.3, all the way to 0.99, any number less than 1, then the series is still convergent. Okay? So x equal to the 0 is the center, right? Center convergent, x equals 0. And we actually can move a little bit away from 0, 0 right here. The series is convergent. How far can we go? We can go all the way to 1, all the way to -1, but not including the endpoints, okay? When x equal to 1, this is 1 plus 1 plus 1, all the way, add all the ones together, you got infinity. When x equal to -1, you got 1 minus 1 plus 1 minus 1, you got an alternating series. It's also convergent. Divergent. So the interval convergence, we're talking about all the real numbers between -1 and 1 right here. And this we call what? The interval of convergence. Okay? The center is right here at 0, center. Center of convergence 0 for sure. The series will be convergent at the center. And then it can move a little bit to the left, a little bit to the right. Okay? And how far can it go? To the left, to the right? And this is 1. And this distance from here to here is called r, the radius of convergence. Okay? So in this particular example right here, the center is x equal to 0 and r is equal to 1. And you know that the interval convergence will be 0 plus or minus 1, which is from -1 to +1. Okay? The center plus or minus, let me write this way. The interval convergence will be 0 minus 1 all the way to 0 plus 1. Start from center, you move 1 unit to the left, and you add 1, you move 1 unit to the right, you have the interval convergence, which is -1 to +1. So let me just give you a theorem about the interval conversion, and I will show you a couple of examples, I think maybe 3, and you'll see how we find the center and radius of convergence of the power series. So let me write in general, okay? You have a power series Cn x minus a to the n, which is C0, C1 x minus a, C2 x minus a squared, C3 x minus a cubed. This is a power series center at x equal to a, okay? And say with the radius of convergence r, then we have 3 cases. If r equal to 0, then the interval of conversion will be a minus 0 to a plus 0. We don't write that with the interval conversion, which is 1.8, okay? Because the center is right here. Center is at a, right? You move 0 unit to the left, 0 unit to the right, okay? When the second case, when r is bigger than 0 but less than infinity, then you have the interval conversion is going to be a minus r all the way to a plus r. And graphically, a is right here, go to r, and then right, r is right here, r is right here. So this is a plus r, this is a minus r. This one right here. A is the center. You go a little bit to the left, a little bit to the right. And the third case is r equal to infinity, and basically you have what? A minus infinity and a plus infinity, and this is really the whole real number. So instead of writing this way, people write what? Negative infinity to positive infinity. Okay? R equal to infinity, all the way to the left. And this one will say what? The power series, or later on you learn about series in general, only conversion at the center at x equal to a in here. The radius of conversion equal to 0. It cannot be conversion to any other point beside the center. Okay? And this, say what? The radius conversion is r, which is finite numbers, positive finite numbers. If 1, 2, 3, 1.5, something like that, then you have an interval conversion. Center, and then if you move a little bit to the left or to the right of the center, the power series is still conversion. You move too far, it's divergent. And the third case, what? R is infinity means what? Doesn't matter what value of x, the series will always be convergent. Okay, so the main type of problem you guys are going to see in this section is that they're going to give you a power series, and they ask you to find the radius or the interval convergent. And as I mentioned already, hint is what? Using the ratio test to take care of the problem. And the only thing that I haven't mentioned yet is what? The endpoints, okay? The power, the interval convergence. Sometimes it is square bracket or parenthesis, and I will show you how we figured it out. So let's start with the first example. X minus 4 right to the n over n. Okay? And run from, say, 1 to infinity. Okay, so this is what? X minus 4 plus x minus 4 squared over 2, x minus 4 cubed over 3 plus dot dot dot. So in here, C0 is equal to 0, C1 is equal to 1, C2 is equal to 1/2, C3 is equal to 1/3. So in general, Cn is equal to 1 over n, and starting from 1, bigger. Okay? And center is at x equal to 4. Okay, so you know for sure when x equal to 4, that series will be convergent. X equal to 4, all the terms equal to 0, so add all the zeros equal to 0. So the series is equal to 0, it's convergent. What if, say, x equal to 4.1, 4.2? Is that still convergent? Let's figure it out. And the test we're going to be used always. For this type of problem, we're going to use the ratio test. Remember the ratio test? We're going to take the next term divided by the previous term. And then we take the limit for n go to infinity. So an is equal to x minus 4 raised to the n over n. And then an plus 1 is equal to x minus 4 raised to the n plus 1 over n plus 1. Alright, now I'm going to get an plus 1 divided by an. Then later I'm going to take the absolute value and then take the limit when n go to infinity. This is what? This number divided by this number, so x minus 4 to the n plus 1 over n plus 1. Everything divided by x minus 4 to the n over n. Divide by fractions means you guys multiply by its reciprocal. So x minus 4 to the n plus 1 over n plus 1 multiplied by n over x minus 4 to the n. And then cancel out the x minus 4 to the n. I got n over n plus 1 on top, n here, n plus 1, then times x minus 4. Okay? So if I take the absolute value of this, I will have absolute value all over, and this is absolute value. Okay? And then now I take the limit when n go to infinity. N go to infinity, n over n plus 1 will go to 1. Okay? So this is go to x minus 4 as n go to infinity. Okay? So the limit of the two consecutive terms, an plus 1 over an is equal to x minus 4. So it really depends on x. Okay? And the ratio test say what? If that limit right here equal to 1, and you say something, it's less than 1, you say something, it's bigger than 1, you say something. Alright? If it's equal to 1, what does it mean? That the test is inconclusive. It means that you have no idea. Less than 1, what? It's convergent. But more than that, the series is absolutely convergent. If that limit is bigger than 1, then it's divergent. So we have to take care of 3 cases. I need to erase something, so let me erase the point right here. Okay, so the limit right here is equal to x minus 4, absolute value. So 3 cases. First case, if x minus 4 is less than 1, and what do we mean by x minus 4 absolute value less than 1? That means negative 4 is less than x minus 4 less than 1. Okay, absolute value. And this is what it means, and this is what it means. What? You add the 4 on all the sides, so 3 less than x less than 5, and the series is absolute convergent. Okay. And you see the radius come from here as well. The radius is x is 4 is center, right? You go 3 to 5. Center is at 4, we know that. And then 3 to 5. And you see that the radius r is equal to 1. So if they ask you for radius conversion, answer is r equal to 1. Interval conversions from 3 to 5. Not done yet. What about the endpoint? Is that conversion at x equal to 3, or is conversion at x equal to 5, or if they are divergent at both? We don't know. We have to test. And how do we test for that? We just plug in the ending value, the endpoints. So for now, we know that the series is convergent at the interval 3 to 5. Okay? Now we have to take care of the endpoints. Endpoints. It may or may not be convergent at the endpoints. We have to test for it. So test for x equal to 3. Endpoint on the left right hand. X equal to 3. The series is what? 3 minus 4 raised to the n over n run from 1 to infinity, which is what? 3 minus 4 is -1. 1, so -1 over 1. N equal to 2. 3 minus 4, -1 to the 2 is 1 over 2, and minus 1 over 3, plus 1 over 4, minus 1 over 5, plus 1 over 6, minus harmonic alternating series. This is actually a conversion series. We learned that before. Okay? You guys can use the alternating series test. The term is increasing, ignoring the sign, okay? It's decreasing. 1, 1/3, 1/2, 1/3, 1/4. Decreasing, limit go to 0. Alternating series test say this. This is convergent. Okay? So x equal to 5. You have the sum of 5 minus 4 to the n over n run from 1 to infinity, and this is 1 plus 1/2 plus 1/3 plus 1/4. And this is the harmonic series that we learned before. This is divergent. So if you have the first example, you see what? So the endpoints right here have two cases of the first endpoint was converging, the second endpoint is divergent. So you have to change this a little bit. It's not parenthesis on both sides. The correct answer will be this. Okay? This is open on the right and closed on the left. What? This is convergent all the way from 3 to 5, including 3, excluding 5. Alright? So the first example right here, I'll try to show you a technique how to tackle a problem about how to find the radius or interval of conversion for a power series. So first of all, you find the center, right? And then you take use the ratio test. Take the an plus 1 term divided by an term. You take the limit when n goes to infinity, and then you set the limit less than 1. You set the limit equal to 1. Of course, it's bigger than 1, and the series divergent already. We do less than 1, we do equal to 1, and the rest will be greater than 1. Okay? We have the limit, and we solve the limit. We find the interval conversion, we find the radius conversion, and after that, don't forget to test for the endpoints. Okay? X equal to 3. This example, the series is actually convergent. X equal to 5, the series is divergent. So you have the interval conversion right here. This is the radius conversion. This is the interval conversion. Interval of convergence. Okay, let me give you another example. Let me show you some example that the series I think is convergence just 1 point. How about this? N factorial times x minus 2 to the n. Okay? And run from 0 to infinity. And this is 1 n equal to 0. 0 factorial is 1, right? Plus n minus 2. Oh, sorry, x minus 2. That's what I meant. And then 2 factorial x minus 2 squared. 3 factorial x minus 3 cubed. Plus dot. Okay? So the center is x equal to 2. Okay? This is a power series center at 2. And A0 is, book you C, so let me use C. C0, the constant is 1. C1 is 1. C2 is 2 factorial. C3 is 3 factorial. So in general, Cn is n factorial. This is the first sum, C0 right here. C1 is, I got a 1 right here. It's 1 factorial, 2 factorial, 3 factorial. Okay. All right. So using the ratio test, right? To find the radius conversion and the interval conversion. Of course, you know that this series conversion when x equal to 2. Because as I said before, when x equal to 2, this term is 0, that term is 0, all the terms equal to 0 except for the first term. So the sum of the series will equal to 1 when x equal to 2, for sure. then we're going to test. We see if it's convergent somewhere beside x equal to 2. We're going to use the ratio test. And to use the ratio test, we have to find the two general consecutive terms. So an, the general term is going to be n factorial times x minus 2 to the n. And then the next term, an plus 1, will be n plus 1 factorial times x minus 2 to the n plus 1. And for the ratio test, we have to make a ratio between the two consecutive terms, so an plus 1 over an